In this module, we move from theory into a concrete banking scenario. You'll see why a bank invests in remote onboarding and qualified e-signatures, what good looks like in practice, and which business and regulatory requirements will shape your later design choices. You've already covered the foundations: what digital identity is, how eIDAS works, and the key technical building blocks. Now we'll anchor those ideas in a real-world banking example, define the business goals and constraints, and use them to drive both the user journeys and the overall architecture. Imagine a customer on their couch, opening a new bank account without ever visiting a branch. They start in a browser or app, enter their data, and their identity is checked using compliant remote verification. The bank presents the contract and terms digitally, just like a paper pack. The customer signs using a qualified electronic signature with full legal value under eIDAS. The bank then stores all evidence and activates the account right away. To keep this initiative realistic, we deliberately narrow the scope along 3 dimensions. First, channels. We focus on digital self-service via web and native mobile apps. Branch kiosks, call centers, and paper flows stay out of scope, so the team can move faster. Second, geography. We start in 1 or 2 EU countries, but design every decision for reuse across borders under eIDAS. Third, products. We begin with everyday current and basic savings accounts, leaving room to add credit, loans, and investments later. In this scenario, our system concentrates on the very first moments of the customer relationship. We want to prove a new retail customer's identity, capture a qualified e-signature on the account opening contract, and store all related evidence for audit and compliance. We are not building the core banking engine, a full fraud platform, or complete lifecycle processes. Those remain external systems that we connect to through clear, well-defined interfaces. An eIDAS onboarding journey only works when it balances 3 perspectives. Customers expect to sign up from their couch in minutes, with simple language, few steps, and strong confidence that their data is protected. Business owners focus on conversion, reaching customers beyond branches, and scaling growth without overloading operations. Compliance and risk teams need the same flow to be fully aligned with eIDAS, AML, and KYC, so growth doesn't generate legal or regulatory problems. Beyond those groups, you're also balancing 4 powerful voices. IT and architecture look for clean integration, scalability, and clear ownership of components over time. Security concentrates on data protection, fraud prevention, and strong authentication, backed by logging and incident response. QTSPs provide the qualified certificates and signing services, so they need robust integration patterns and clear SLAs. Regulators measure everything against eIDAS, AML, and local rules, demanding evidence, audits, and proof that controls actually work. Architecture is the discipline of turning all these stakeholder tensions into concrete requirements. Customers want a smooth journey, while security teams want strong defenses. So you design flows that adapt checks to risk and clearly show trust and consent. Business wants a fast launch. Legal demands rigor. So you reuse pre-approved certified components wherever possible. Finance pushes for predictable spend, while IT plans for future change. So you define modular services and clean contracts with providers. And for regulators, you build evidence so every control can be traced back to their rules. eIDAS is the EU regulation that lets digital signatures stand in for ink on paper. It defines different levels of electronic signatures and states that a qualified electronic signature is legally equivalent to a handwritten one. To reach that level, we must rely on certified trust service providers, and those qualified signatures are then recognized across all EU countries. AML and KYC rules are the main regulatory drivers behind remote identity proofing. They require banks to know exactly who they are dealing with, assess the risk each customer poses, and prevent money laundering or terrorist financing. As a result, remote identification must be as strong as face-to-face checks, while still flexible enough to meet each country's specific expectations. When we design identity proofing and signing, we are really defending against 4 risk patterns. First, identity fraud. Someone pretends to be a new customer using stolen or synthetic data. We counter that with high assurance proofing, document checks, and fraud telemetry. Second, account takeover. A real customer's channel is hijacked, so we rely on strong customer authentication and step-up checks for high-risk actions. Third, QES abuse, misuse of qualified signatures, controlled through clear consent ceremonies and strict issuance. Finally, operational failures, mitigated with monitoring, alerts, and robust exception handling. Regulatory risk doesn't just sit in a policy document. It turns into specific technical requirements. To control identity fraud, you need high-assurance onboarding, often using national eID or supervised video identification that meets AML and KYC expectations. To prevent account takeover, you apply strong customer authentication with at least 2 independent factors. For contracts, especially account opening, a qualified electronic signature backed by a QTSP and a full audit trail delivers legal robustness and traceability. Here's the functional backbone of our solution. We start with a strong identity proofing engine. It captures documents and data, runs authenticity and liveness checks, and connects to compliant eID providers. Next, configurable onboarding that tailors flows to each product and automatically generates the right contracts and disclosures. Then, a qualified signing journey with strong authentication and explicit consent. Finally, an evidence layer that stores all logs and supports clear approve, reject, or review decisions. Non-functional requirements turn a working solution into a trustworthy one. Security and privacy protect sensitive identity and signing data, while meeting regulations such as GDPR. Availability and performance keep onboarding and signing reachable and fast enough that users don't abandon the flow. Usability and accessibility make journeys understandable and inclusive for all users. And scalability and extensibility prepare the platform to grow into new countries, products, and trust service providers without major redesign. You now have a clear, regulated use case, a set of stakeholders, and a structured list of functional and non-functional requirements. Next, we'll turn that picture into concrete user journeys and UX, and then use those flows to outline a high-level architecture.